So today what we are going to do, we are going to do what? Transmission of heat. So till now what we have done,
Definition of heat,
basically we have just studied the properties of heat.
properties.
Clear? Just like in your electrostatics, what we used to start with? We used to start with electrostatics.
Electrostatics.
You all know, where we study the properties of charges and something and something.
Yes.
Those, after that, what did we do? We went to electrodynamics, or basically your electricity. Moving charges produces your electricity, no? So in that, what we studied about your resistance, conductivity, something and something. Basically, how they react or how they react with other material, basically. Clear? So first we study the properties, what is heat, and after that, how it will react with other material, that we have to study. And basically that is called your transmission of heat. Clear?
Yes, sir.
One of you users unmute. Who has a good internet connection? Just one of you just. I think Deepika has a good connection. Deepika, you just unmute your mic. Okay.
Yes, sir.
So basically conductivity you have all studied about in your electricity. Have you all studied?
Yes, sir.
So basically in this was conductivity was given by what here? Flow of what? Charges. Flow of charges basically. Similarly, a conduction is given by what in terms of heat? Conduction is given by flow of heat. Clear?
Yes, sir.
So during your electricity, how the current used to flow? It used to flow from higher potential to
Higher to lower.
higher to lower. So what about in heat? So it will flow from the region from higher temperature to lower temperature. Clear?
Okay, sir.
I think everyone can hear me. So it basically flows from what? Higher temperature to lower temperature. Clear? So basically there are three modes of transmission of heat. One is here, first is your conduction. Do you know what is conduction? Conduction of heat. Anyone? Conduction, modes of transmission of heat by conduction.
Sir.
In previously in electricity also you have studied about what conduction, and after that what it was?
Frictional.
No, one was conduction and another one was, there was two modes.
Convection.
Not convection, no.
Conduction.
In conduction what you used to do? You usually used to, the two body used to be in contact, if you all remember. And there was another mode where you used to do what? Polarize, if you all remember.
Alright.
Induction, do you know? Conduction and induction,
Yes,
I
sir.
think you have all studied previously. So conduction is a very basic form of what? Here, transmission of heat. So in conduction, what? The first most important criteria is two bodies should be in contact. Clear?
Yes, sir.
So here, can you see? I think this you all know. This is the form of conduction.
Yes, sir.
Just like while cooking, the pan starts getting hotter and hotter. This is due to the fact that the heat has been transmitted through conduction. Clear? Now over here, the heat is transmitted.
Yes, sir.
Over here, the temperature will be higher as compared to here. Will it be higher or lower?
Yes.
On which
Higher.
side it will be higher and on which side it will be lower? Towards your left, I think, which is very close to your fire, will be at higher temperature, and this will be at low temperature. So what will happen? The heat will start flowing. Clear? So this is basically your form of conduction. So actually this is again due to the what? Flow of free electrons. Clear? Basically these free electrons, what they do, they carry this energy. How do they carry energy? Because they keep on gaining energy, so the kinetic energy increases. Clear? So it collides with another one and it will transfer its heat in that manner. So the electron will be highly excited on this region. It will start moving and it will bounce with some of the other electron and it will pass some energy and so on and so forth. So the furthest away, it will be at the lowest temperature. Clear?
Yes, sir.
So let me ask you, what are the good conductors? Gold. What? Gold.
Metals.
Okay. Metals. Okay. Apart from that, good conductor. Okay, what about bad conductors?
Bad conductors, wood,
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 okay, very good.
We have
plastic,
free electrons.
Plastic, very good.
Sticks,
Okay.
rubber,
Now, insulators are completely different. Insulator, basically, they don't what? Conduct at all. Basically, those are dielectrics. I think you all remember.
yes, sir.
So basically, your type of good conductors are what? Your metal,
Aluminium,
like something copper. I think most easily formed
copper,
and
yes,
cheap
sir.
is
Aluminum,
copper. Actually,
Silver.
platinum. Yeah, so on and so forth. All the metals.
aluminum, and the
Okay,
plastic.
aluminium. Okay. So what about the bad conductors? What about the bad conductors? Wood. Someone was saying
Wood,
woods.
plastic,
So plastic. What about helium? Helium, neon,
oh
argon, and
yes,
all.
sir.
Do they conduct?
air,
No,
So
they don't.
what is the difference between these two? Why this is considered as a good conductor and this is as a bad conductor? What is the difference between these two?
Helium absorbs zero free electrons.
Okay. Means the whole idea is free electrons.
Yes, sir.
Clear? Actually, the whole work is done by a free electron. Free electron usually they transfer a heat from one side of the body to the other side. Clear?
Yes, sir.
Usually what happens when you heat a metal bar, the electron starts getting that energy and its kinetic energy increases. Clear? It starts getting excited. Clear? So as the electron keeps on moving, so as the kinetic energy of the electron increases, which means your velocity increases now. Let's not say velocity, let's say your speed. It increases. Clear? So it collides with another electron. As it collides with another electron, what it will be? Considering that as it is an elastic collision, what will happen? What usually occurs in your elastic collision? Have you studied about elastic, non-elastic collision?
Yes, sir.
In elastic collision, what are conserved? In your non-elastic, I will tell you, only momentum is conserved. So what will be conserved in your elastic collision?
Potential. Yeah.
Basically, your energy.
Energy.
Basically, what will be conserved here? Kinetic energy
No net.
or energy
Kinetic energy.
and or basically energy. Yeah, kinetic energy is conserved, and after that, what? Momentum. Clear? Linear momentum. Any linear momentum will be conserved because it's very simple. Now, let us consider two scenario. One, let's consider this as a very hard rigid ball, which is completely elastic in nature. Clear?
Yes, sir.
So that it's completely hard, so that it does not get deformed. Clear? Now, these two bodies are coming closer to each other with certain kinetic energy. After collision, what will happen? As soon as they hit each other, they will start bouncing off each other. Clear? They don't get deformed. So whatever the energy which was coming previously will be
Yes, sir.
conserved. Clear?
Conserved.
Now let's consider the another scenario. Here your two bodies are not completely rigid or elastic. Let's consider. So these two bodies are coming towards each other. Clear? Now as soon as they collide, what will happen? As they are not completely elastic, they will start getting deformed. They will be, after collision, they will be like this, in this form. So some of the energy get, so this will start again in this shape. It will start moving on this side, and with this shape it will start moving in this side. So here whatever you had initial kinetic energy is not equal to your final kinetic energy. Just like your car collision. Do you remember?
Yes, sir.
That is non-elastic or inelastic collision. Inelastic or inelastic collision. So now let's move back to our electron. Suppose we considered here electron is what? Goes through a completely what? Elastic collision. Then whatever the energy it was carrying, it get distributed. Clear?
Yes, sir.
So let's say the electron was coming in this way and it get bounced with this electron. Clear?
Yes, sir.
So after maybe it may be randomly moving in this direction. So after collision, what? This electron will move to a say heater side, and this will again move with higher kinetic energy. Again, it will collide with another. So that's why the heat will keep on get distributed. Clear?
Transfer. Yes,
So
sir.
over here, if we plot the temperature will be highest and it will start decreasing slowly. Clear? So your initial temperature will be on this side will be highest, and over here it will be lowest. So it is due to a fact that electron keeps on heating and it keeps on losing its energy as it keeps on moving to the other end. Clear? So that's why this is at lower temperature. Clear? This is at higher temperature. So eventually, if you keep on heating, the total velocity of this system will increase, so that the bar will be uniformly heated after certain time. I think it's clear till here.
Yes, sir.
So now we will move with the most important property, that is your conduction. Conduction, I think we have studied what is conduction. Sorry, conductivity. So what do you mean by conductivity? What is conductivity? What is conductivity? In general sense, not from the point of view from the heat, from in general, what is conductivity? Do you all know what is conductivity? I don't need the exact definition, just a rough idea will also do.
So it is which is the flow of electrons, charge, heat.
Flow of charge, electrons.
Easy flow of charge.
Okay, easy flow. Okay. So higher the conductivity, higher
Lower
the
will be the
no, basically higher the conductivity, you are telling that it will be easier for heat or anything to flow. So higher the conductivity,
Lower the resistivity, sir.
higher will be the flow of charge.
flow of charge. Yes, sir.
Okay. Higher will be flow of charge. So higher the flow of charge means, so higher will be the what? The flow of heat, transfer of
Flow of
heat.
heat,
Okay, higher will be the
transfer of heat.
transfer of heat. So is this the intrinsic property of all the material? Will the conductivity will be constant, will be same for all the material? Or is this intrinsic to different material? So different material will have different conductivity, or all the material will have the same conductivity? What do you all think?
So different material will have different
Okay. Okay, different materials will have
Different
different
conductivity.
conductivity.
different conductivity. So basically it is an intrinsic property. Different
Yes, sir.
conductivity.
Yes, sir.
So this is an intrinsic property. Intrinsic property. So it is an intrinsic property. So as you have all studied previously, so what are the different factors the conductivity will depend on? First, let's consider the extremely long bar. Is the figure visible?
Yeah.
Yes,
Yes,
sir.
sir.
And let's consider another bar of same area but shorter. Clear?
Yes, sir.
So
Yes,
you
sir.
start heating over here. You provide heat over here by burning candle or something. Okay, you start heating over here.
Govind sir,
On which side do you think the heat will be transferred faster? In this metal rod or in this metal rod?
sir, second one.
Second one, the heat will reach faster over here because it is shorter. Because both are made out of
Yes,
same
sir.
material, both are have a same equal area of cross section. So the heat will reach faster because it is shorter. So one thing we know
Yes, sir.
that
That is
your
proportional to length.
flow of heat which is should be proportional to your length of a bar. Longer should be inversely proportional to your length of a bar. Is it clear?
Inversely. Yes, sir. Yes, sir.
So if we consider the same scenario, but we increase the area of cross section.
Area.
If we have consider another scenario. Where you have this kind of thing. Clear? Of equal length. Clear? Of equal length. And
Yes,
you
sir.
have this. On which do you think the heat will be transferred faster? Over here or over here?
Upper one.
Okay, down one. Sultim is telling
So
down
the
one.
down one.
And what about the others? Okay,
Upper
one.
The one.
Upper one. Actually, the answer is upper one. Why? I will tell you. Because the area of contact, if you start heating over here, the area of contact will be more. So as a whole, this whole thing will be what? Heated faster as compared to this. So there will be more free electrons.
More free electrons
Also, it
also,
will
no,
be
sir?
easier for them to move. Clear? It's just like a traffic jam. Traffic jam is
Yes,
more
sir.
in here.
Yes, sir.
Let's say you can only have one car over here, and here
Yes, sir.
simultaneously you can have two lane. So that's why your heat will be flow faster in this region. Clear? So second point what we can write is, Sultim, is it clear?
Which is a volume if volume is greater than
No, not volume, area of cross section. Clear? Both are of same length. Volume may be different. Clear?
volume theorem. So sorry.
Now I will give you another scenario, okay? Not volume. Right. What about this scenario? Here, Tultim, let's say yeah, in a sense, in a volume, okay, let's say. But it will not depend on a volume, okay, Sultim, because this one is longer and this one is shorter. Let's say both has the same volume.
Yes, sir.
On which do you think the heat will flow faster? On the top one. Why? Because this area is longer and what? Your
Area of cross section is
is
greater.
area of cross section is bigger, but your length is shorter. So obviously the heat will flow faster here and slower in this case. But both have the same volume.
Yes, sir.
Understood? Sultim? So that's why.
Yes, sir.
Yeah, Rita? So second point is your heat will be proportional to what? Area of cross section. Clear?
Yes, sir.
So if you do you all remember? So higher the potential, faster the or more the current will be, faster it can transfer the energy. If you all remember, V is equals to IR. Do you all remember this relation?
Yes, sir.
So higher the potential, higher will be current. Do you all know this? So similarly,
Yes, sir.
higher the temperature gradient or higher the
Yes, sir.
difference of temperature, the faster will it flow or not. This, let's say this has 100 degrees
Yes,
Celsius
sir.
and this has 10 degrees Celsius. So higher the difference in temperature, the faster it will flow. Or I think this is very, or it is clear from your
Yes, sir.
Newton's
Yes,
law
sir.
also. Do you know Newton's law? Q was proportional to what? T minus T naught. In a similar manner, it will be basically the gradient will be more over here. Clear? The temperature is more over here and this is less over here. Let's consider another scenario. You have the same situation, but the temperature is 11 degrees Celsius and 10 degrees Celsius. Now, how long it will take for your energy to reach here? It will take you extremely long. So that's why the heat is proportional to your difference in temperature. Clear? Is it clear? From the Newton's.
Yes, sir.
So it will be basically difference of, should I use θ1 or T1, T2? Should I use T1, T2 or θ1, θ2? T1 minus T2. Is it clear now? Is it clear?
Yes, sir.
Yes.
Now finally, it will depend on what? It will depend on what? It will depend on what?
Material.
If you hit this, yeah, that is correct. If they hit this this side of a metal bar for 1 second, and if you hit this side for what? 10 minutes. Where the heat transfer of heat will be more? Or where the heat will be more?
10 minutes, sir.
Okay. So you can write your heat is proportional to the time.
Yes, sir.
Is it okay?
Yes, sir.
Now if you combine all this, what you will get?
1 constant and TA by L.
Or basically what you can do is, basically your can write this. This is basically rate of flow of energy or rate of flow of. This is basically what? Rate of flow of heat. Can we write this?
Yes, sir.
Is it clear to everyone? Q by T is basically what? Rate of flow of heat. So rate of flow of heat is proportional to 1 by L. Is this clear?
Yes,
So
sir.
longer the length, the faster it will flow. Rate of flow will be more. So rate of flow of, with respect to area, will be this one. So rate of flow will be proportional to the difference in temperature. Is this point clear? Either way, you can either go from this way or this way. I think both way is correct. So if you combine this whole equation, what you'll get is proportional to what?
Q by
A
L.
T1 minus T2 divided by L.
Yes,
Is
sir.
this point clear?
Yes, sir.
Now, if you remove this proportionality constant, what we'll get? Some constant.
K. Constant.
And you'll get a relation like this.
Yes, sir.
Now, what is this K is called? K is basically called here coefficient of
Heat.
thermal conductivity.
Oh.
So whatever Sulting was telling previously is correct, that this thing will depend on different material. For different material, this will be different. So that's why the rate of flow will depend on what?
Oh, yes, sir.
Material.
On different material. For different material, K will be different. So just guess what will be the K for insulator?
0.
Oh, very good. So K will be 0 for insulator because it does not allow the heat to flow. I think it's clear till here. So what was your A? So the rate of flow was proportional to your area. Larger the area, the faster it will flow. Inversely proportional to rate. So and higher the difference in gradient, the faster it will flow. Clear?
Yes, sir.
Yes, sir.
And what was this K? K was called a coefficient of thermal conductivity, which depend on a different material.
Material.
So what will be the unit of K? What will be the unit of K? Should we do the dimensional analysis? So it will be easier. Let's consider the dimensional analysis. Okay. So Q will have what? Dimension of what? Calorie. So what is the unit of time? Anyone, what is the unit of time?
Second.
Good. Area? Meter
Meter
square.
square.
Meter
Length?
square.
Meter.
Meter.
What is
Meter.
T1 minus T2 will have? Degree Celsius.
Degree Celsius.
So if you put everything over here, Q by S will be basically what? Calorie per second. So K, we don't know the dimension of this. This is basically meter square divided by meter. This is basically degree Celsius. That's it. If you cancel this two, basically the unit of thermal conductivity is what? Calorie meter degree Celsius second. Clear? Is this clear?
Yes, sir.
So from this, I think we can define what? Definition of K also. If you want to construct the definition of K, if we have a energy of 1 calorie, length of 1 meter, temperature difference of what? Temperature difference of what? 1 degree Celsius and time of 1 second. So what will you get? Or basically, if you what you will get? Or if you just remove this, instead of calorie, you can just write K is equals to calorie. You just put Q by meter second, degree Celsius second. So basically, a K will be, if you put all the value, K was what? Q by what? Q by A. Q by A, L, and after that, what did you have? Second, in degree Celsius was where? T2 minus T1 was where? It was over here with area. Now, if you had length of 1 meter, area of cross section 1 meter, time of 1 second, temperature difference of 1 degree Celsius, then you will end up with what? K is equals to Q into 1 divided by 1, or basically Q. So thermal conductivity is basically the amount of heat, clear? Amount of heat flowing in 1 second in what? Across a force of cube of side of what? 1 centimeter or 1 centimeter maintained at a difference of 1 degree Celsius. Sorry, this should be in a centimeter. So basically, if you consider a cube of unit centimeter square of each of 1 centimeter. So let's say this phase. So this phase was at what? High temperature, let's say 11 degrees Celsius. 11 degrees Celsius. And the colder one was at what temperature? At 10 degrees Celsius. Clear? So the amount of heat which is flowing in 1 second from this side of the tube to this side of the tube is basically called a thermal conductivity. So actually we'll again do it in your next lecture. I think after this you'll have continuous lecture. We'll again start from this part. Clear?